Hello everyone. For today, we will be learning all about ellipse. An ellipse is a set of points such that the sum of its distances from the two fixed points is constant. Now take note with this ellipse, the two fixed points are F and G, or they are considered as the foci. This point P here is on the ellipse. Now take note as I drag this point anywhere on the ellipse, the distance from F to P and P to G will also adjust accordingly. But the sum of these two distances will remain equal. Now these are the basic parts of an ellipse. It has a center and it has major and minor axes. For the major axis, it starts with the vertex and it also ends with another vertex. So basically, the major axis contains the two vertices, the two foci, and of course the center, while the minor axis starts from co-vertex 1 and ends with co-vertex 2. Now take note with this one from the center going to the vertex, it's denoted with A, while center going to the focus is represented by C, while the center going to the co-vertex is represented by the distance B. Now take note, distance from the focus going to the vertex is equal to the distance from the vertex going to this line, and this line is considered as the directrix. Now there are two kinds of ellipse. An ellipse could be horizontal, in which the standard equation is x squared over a squared plus y squared over p squared equals 1. Or it could be vertical, in which the standard equation is x squared over p squared plus y squared over a squared equals 1. Now take note that a is greater than p, or a, which is center to vertex, is always greater than center to co-vertex. Now what does it imply? Therefore, it means that the bigger the denominator is, it implies the kind of ellipse. For example, if the bigger denominator is under x, so therefore it's horizontal. But if the bigger denominator is under y, therefore it is vertical. Another thing is how to find the distance from the center going to the focus, or the focus distance C. To do this, we will use the equation C squared equals A squared minus B squared. Now find the foci and the coordinates of the foci, the vertices, and the co-vertices of the given. In this case, the bigger denominator is under x, so therefore this is a horizontal ellipse. So since our a squared is 25, so therefore our a is 5. Our b squared is 9, so therefore our b is 3. And to find c, we will simply substitute. 25 minus 9 is 16, therefore get the square root to both sides, so therefore our c is 4. Now, how to sketch this in the Cartesian plane? So since this is a horizontal ellipse and our A is 5, from the center, count 5 points to the right and 5 points to the left. And since our B is 3, from the center, count 3 points going to the top and 3 points going to the bottom. And since our C is 4, from the center, count 4 points to the right and 4 points to the left. And to do this, we will simply connect the co-vertices and the vertices with a smooth curve. And since focus to vertex is 1, so therefore vertex to the directrix is also 1. With this, we can identify our vertices as plus and minus 5 and 0, and the foci is plus and minus 4, 0, while the co-vertices is located at 0, plus and minus 3. Another example. If we're given this, the bigger denominator is under y squared. So therefore, this is an example of a vertical ellipse. Since our a square is 25, so our a is 5. And our b square is 9, so therefore our b is 3. And to find c, we will simply substitute 25 minus 9, so therefore it's 16. So we will end up with 4. Now, how to graph this in the Cartesian plane? So since this is a vertical ellipse, from the center, our a is 5, 5 points to the top and 5 points to the bottom. And our b is 3, from the center, 3 points to the right and 3 points to the left. And since our c is 4, from the center, 4 points up and 4 points down. Again, connect the vertices and the co-vertices with a smooth curve. And this is 1, so vertex to the directrix is also 1. With this, we can identify our vertices as 0 plus and minus 5. The foci is 0 plus and minus 4, while the co-vertices are located at plus and minus 3 and 0. Now, what if the center is no longer the point of origin? How to do this one? Now, let's have an example. If we're given x plus 3 square over 24 plus y minus 5 square over 49 equals 1. In this case, the bigger denominator is under y. So therefore, this is a vertical ellipse. So since our a square is 49, so our a square root of 49 is 7. Well, our b square is 24. Get the square root to that. So b is 4.9. And to find c, we will simply substitute 49 minus 24. So therefore, we'll end up with 25. Get the root, so the result would be 5. And since our center here, it's negative 3 and positive 5. Now to graph this in the Cartesian plane, locate first the center, which is located at negative 3 and 5. So it's here. Since our a is 7, from the center, count 7 points to the top and 7 points down. And since our b is 4.9, from the center, count 4.9 to the right and 4.9 to the left. And since our c is 5, from the center, count 5 points up and 5 points down. And again, simply connect the vertices and the co-vertices with a smooth curve. So basically, this is our graph. So let's identify the basic points. So for the vertices, it's located at negative 3, negative 2, and negative 3 and positive 12. Well, the foci, it's located at negative 3, 0 and negative 3, 10. While the co-vertices, it's located at 1.9 and 5 and negative 7.9 and 5. Another example. The center is located at 7, negative 2. So 7, negative 2, it's somewhere here. Well, the vertex is located at 2, negative 2. So 2, negative 2, it's here. Well, the minor axis ends at 7 and negative 6. Now, in this case, from the center going to the vertex, the distance is 1, 2, 3, 4, and 5. So therefore, to get the other vertex, we will also count 5 points to the right. Now, in this case, from the center going to one co-vertex, the distance is 1, 2, 3, and 4. So therefore, from the center going to the top, we will also count 4 points. So with this, connect the vertices and the co-vertices with a curve. We will end up with this graph. Now in this case, it is a horizontal ellipse. The value for A is 5. Center to vertex is 5. While center to the co-vertex, it's 4. And the center is located at 7, negative 2. So therefore, writing the standard equation of this one, we will have x minus 7 over a, which is 5 square or 25, and y plus 2 squared over 16, in which it's 4 to the power of 2, is equal to 1. So therefore, this is the standard equation for the given. Another example. In this case, a graph is given. It is a vertical ellipse. The center is located at -3 and +5. From the center, going to one vertex, it's 7. And from the center, going to one co-vertex, the distance is 5. So writing this in the standard equation, that would become x plus 5 squared over 25 and y minus 5 squared over 49 is equal to 1. So 49 is bigger than 25 and it is under y because it is a vertical ellipse. Convert the given to standard form. So to do this, group all x terms and y term together and the constant to the other side. So for this one, for x term, 3 is common. So factor it out. So we'll have 3 quantity x squared minus 4x. For the y terms, the common is 7. So factor it out. We'll have y squared minus 4y. At this point, complete the square. Half of -4 is -2. Square it. We'll have 4. So we add 4 here. So the same thing for y term. So add 4. So we add 4. So we also add 4 to the other side and times 3. Then plus 4 times 7. So at this point, rewrite to binomial form. Square root of x squared is x. And square root of 4 is 2. Sign of the second term is negative. So the same thing here. So at this point, divide the entire equation by 21. So we will end up with quantity x minus 2 squared over 7 plus y minus 2 squared over 3 equals 1. So the general form is this one and its corresponding standard form is this one. And they are exactly the same ellipse. Situational problems involving ellipse. A tunnel has the shape of a semi-ellipse that is 15 feet high at the center and 36 feet across at the base. At most, how high should a passing truck be if it is 12 feet wide for it to be able to fit through the tunnel? Now take note, the given includes 15 feet high and 36 feet across. Sketching this, we will have this one. Now take note, it's 15 feet high, so therefore that is the height of the tunnel. 36 feet across, so get half of it, that would be 18. So from the center, going to one side is 18 feet, and of course it's also 18 feet going to the other side. Another. We have here 12 feet wide. So get half of this, that would be 6. So therefore, this would be the width of the track. So the coordinate here would be 6 and you don't know the height because it is unknown. So given this, we can make the equation as x squared over 18 squared and of course y squared over 15 squared equals 1. Now considering the coordinate 6y, we will simply substitute this in the equation. So with this, we will have this. So substitute x with 6 and y. So transfer 6 squared over 18 squared to the other side. We will get this one. Cross multiply with 15 squared. So simplifying further, we will have y squared equals 225 times 8 over 9 or y squared equals 200. Get the square root to both sides. We will end up with 10 square root of 2 or that is approximately 14.14 feet. So therefore, the track should be approximately 14.14 feet high for it to be able to pass through the tunnel. So that's all about ellipse. Thank you.